Hello children and welcome to your channel Sharda Educare, and in this video we are going to learn problem set of similarity chapter from standard 10th. This is the 14th video and this we will complete in this the entire problem set examples. Let's begin children. We can see on the board 8th sum from problem set and there is a figure. The figure says that there are four lines which are perpendicular to there is a line PA perpendicular to AD, then there is a line QB perpendicular to AD, RC perpendicular to AD and SD perpendicular to AD. So, line 1, 2, 3, 4, all these four lines are perpendicular to line AD. It's given here, perpendicular to line AD. And AB is 60, AB is 60, BC is 70 and CD is 80, PS is PS, this total is 280. Then find PQ, QR and RS. So, these are the things which are given. Let's begin children. So, let us write first what is given. PA is perpendicular to AD, then QB is perpendicular to AD, RC is perpendicular to AD, SD is perpendicular to AD. Now you may say when it is given why to write, what is given we have to write and then that will help us to solve the question which is given. Right here given, for this half marks are there, first point. Now as all these four lines are perpendicular to line AD, so they will be parallel to one another. Therefore, line PA parallel to QB parallel to RC parallel to ST. All these four lines will be parallel to one another. Now you will say why the lines are parallel? See, if this angle is 90 degree and AD is the transversal, RP will be also a transversal. So if you see this 90 degree, what will be this angle? It will be also 90 degree. So 90 plus 90 will be 180 degree. And when the two transversal are there and in between those two interior angle sum up to 180, that means the line will be parallel. So not that means the line will be parallel. This plus this is equal to 180 degree. Now why? Let us begin why the lines are parallel. See, this angle is 90 degree children. This angle is 90, this is also 90. If this is 90 and this is 90, what kind of angle they are? They are nothing but corresponding angles. And if the corresponding angles are equal, this is 90, this is 90, both angles are equal, therefore this line is parallel to this line. Similarly, this is also 90. So, corresponding angles are equal. This is also 90, corresponding angles are equal. Since the corresponding angles are equal, therefore the lines are parallel. Corresponding angles equal and therefore lines are parallel. Corresponding angles are equal, therefore the lines are parallel. If the lines are parallel, we have done one theorem, intercepts made by the three parallel lines. So here we can use that formula. We can say by intercepts made by three parallel lines. Intercepts made by three parallel line or parallel lines. First of all, we will use this upon this is equal to this upon this. Let us use it. RS upon RQ is equal to CD upon CB. CD upon CB. Now how much is CD? Place the value. RS and RQ we don't know, but we know CD value. CD is 80 upon 70. Let us keep it as 1. Now children, as we have proved that the lines are parallel, we will be using the property of intercepts made by three parallel lines. We will consider any three parallel lines and we will be using it. Like we will take SD, QB and AP. Okay. We will take SD line, QB line and AP. So if I am taking SD and QB, so I will have to take the intercept SQ. This intercept I have to take. Okay. Yes. This upon this is equal to this, that is DB upon AB. See, SQ upon QP is equal to DB upon AB. Clear? Let us take that. So, SQ upon QP is equal to DB upon BA. Now here which three parallel line we have considered? SD parallel to QB parallel to PA. Okay, these are the three lines which we have considered. Now if SQ is not given, PQ is also not given, so what is given? SP is given. That means I need to convert SQ in the form of SP. So direct value I can use here. Let's convert this, and that can happen only by componendo, children. If I use componendo, I can convert this SQ into SP. What is componendo? Componendo is SQ plus, what is componendo? See, in 9th standard we have used componendo. Numerator plus denominator upon denominator is nothing but componendo. Yes. What is numerator here? This SQ is numerator and QP is denominator. So if I do SQ plus QP, I will get SP, and that SP value I know that is 280. So I can use componendo here. So let's use that. By componendo. Now why we are using componendo? Because we want to use SP value which is given for us. Okay. So we get SQ plus QP upon QP is equal to, what we will do here, we will also do that side, other side. Here also numerator, this is numerator and this is denominator. So DB plus BA upon BA, using componendo on both the side. SQ plus QP will be what? It will be SQ plus QP will be SP. SP upon QP. is equal to dB plus BA. See, dB plus BA will be dA, dA upon what? BA. Okay, now SP we know, SP value is 280. So we will use SP value here, 280 upon QP we don't know, which is equal to dA. Now dA is what? This total 80 plus 70 plus 60. So we can write directly here 80 plus 70 plus 60. Children, this you should not misunderstand. There shouldn't be any confusion. We are writing dA. And how did we get dA? dB plus BA. See, dB. This is dB plus BA is equal to dA. So 80 plus 70 plus 60 upon BA. And BA is how much? 60. So 280 upon QP is equal to 80 plus 70 plus 60, 150, 210 upon 60, 210 upon 60, 80 and 70, 150, 150 plus 60 will be 210. Now 0 and 0 get cancelled. 6 will go with 280. 280 into 6 upon 21 is equal to, QP will go up. Then 3 2s are 6, 3 7s are. Now 7 1s are 7, 4s are, which will be 40 here. And that will be 40 2s are 80. So QP you will get 80. We got QP as 80. Here we got this as 80. Okay. Now we can easily find out RQ because we will take this line and this line. Now at this time, which three parallel line we are taking? RC, parallel to QB, parallel to PA. Clear? So we can take RQ upon QP. Again we will use the property of the intercept made by the three parallel line, 1, 2, 3. So we will be getting RQ upon QP is equal to CB upon BA. RQ we want to find out, and QP just now we found 80, which is equal to CB is 70 and AB is 60. 80 will go with this, 70 into 80 upon 60. 0 and 0 get cancelled. 2 4s are and 2 3s are. And 7 4s are 28, that is 280 upon 3. RQ is equal to 280 by 3 and QP as 80. So we can, and total we know SP as 280. So I can easily find out SR by using SP plus SP is equal to SP means total is equal to SR plus RQ plus QP, and SP is how much? 280. SR we want to find out. RQ we got 280 upon 3 plus QP we got 80. Now I will be shifting everything this side. 280 minus 280 upon 3 minus 80 is equal to SR. See children, I shifted this side, this also this side. Now what am I getting? Let me rub this. QP as 80 and RQ we got as 280 upon 3. As SR, CP are in one line, so I can take SR plus RQ plus QP, which is equal to SP. And why I can take that? SRQP. SRQP are in one line. This shows that they are in one line. So SR we want to find out, and RQ we got 280 upon 3 plus QP we are having 80, which is equal to SP, which is 280. I'll be shifting everything. I'll be shifting 280 and 80 this side. What will I get? SR is equal to 280 minus 280 upon 3 minus 80. This is upon 1 upon 1. So what I'll do, I should have denominator 3, so multiply this by 3. 280 into 3 upon 3 minus 280 upon 3. See, this do not have 3, so I multiplied it by 3, minus 80 into 3 upon 3, because even this I multiplied by 3, so as to get 3 in the denominator. Now 280 into 3, three zeros are, that is SR. So SR is equal to 300, 3 8s are 24, carry 2, 3 2s are 6 plus 2 will be 8, 840 minus 280. The whole upon 3 can be written as 3 because every fraction has 3 as denominator. Here multiply by 3 minus 3 8s are 240. Now do the subtraction. 840 minus, first this is minus and this is minus, add both of them. 280 plus 240 will come 0, 12, 520. Okay. So 840 minus 280 minus 240 will be added, it will be minus 520. Okay, upon 3. That will be equal to 840 minus 520, 840 minus 520. Subtraction, because one is minus and one is plus. 0, 2, 320. So 320 upon 3 is SR. So we were to find out SR. SR we got here 320 upon 3, 320 upon 3, QR, and a QR we got here 280 by 3, PQ we got 80. So you can pause children and you can solve the sum. Let's begin with the next question. Ninth question, there is a triangle PQR. So this is the triangle PQR, and by this we come to know that this angle is equal to this angle, and this angle is equal to this angle is equal to this angle. This is given here, okay. So we have triangle PQR, PM is a median and this one is median given. Okay, median means it divides the line QR as QM is equal to MR, and it is also mentioned here, QM is equal to MR, fine. It is a MX. MX is the angle bisector of PMQ, and PMR, this is the angle bisector, okay. They divide the side in the point X and Y, means this line M, the angle bisector is dividing PQ at X, and angle bisector of angle PMR is dividing the side PR at Y. Clear? So, and it is also given side XY is parallel to QR. XY means this side is parallel to this side, fine. So, complete the proof by filling the boxes. In triangle PMQ, see the triangle PMQ, children. PMQ, this triangle, okay. In this triangle, ray MX is the bisector. It bisects the angle into two equal parts, and therefore by angle bisector theorem. What is angle bisector theorem? Angle bisector theorem will be PQ upon XQ. I can write here PQ upon XQ. PQ upon XQ. See, not PQ, sorry, PX. PX upon XQ is equal to PM upon MQ. PM upon MQ. Theorem of angle bisector. Now in other triangle, this side triangle, this triangle, that is PMR, which I am tracing with red, which is the angle bisector MY. MY is the angle bisector, okay. It is mentioned here MY is the angle bisector of angle PMR. So therefore we can write PY upon YR, PY upon YR is equal to PM upon MR. PM upon MR. But PM upon MQ is equal to PM upon, I have taken here PM means MP. This PM upon MQ, PM upon MR. PM can be written as MP, no problem. Okay, PM upon MQ and PM upon MR. Both are equal because see here PM and PM, MQ and MQ, MR. But MQ and MR are equal, na? MQ and MR are equal because M is the midpoint. Okay. So these two are equal. Since these two are equal, this is equal to this, we can say that this portion will be equal to this portion. So we can say Px upon Xq is going to be equal to Py upon Yr. And this is what we wanted to prove. What we got? Px upon Xq is equal to Py upon Yr. If the ratios are equal, that means the triangles will be, that means the line XY will be parallel to QR by converse of BPT. So we can say here, you can't see this side, so let me write it here. We can say that px upon xq is equal to py upon yr. Therefore, by converse of BPT, by converse of basic proportionality theorem, line XY will be parallel to line QR. You can pause and you can solve the sum, children. Let's move for the next question.